that you will configure in the WAF. Now, the logic behind security policies is that you want to have, let's say, a baseline in your configuration that covers a lot of aspects regarding web application security. Now, we have created security policies also to help you to configure the web application firewall. This means that as soon as you basically deploy the WAF and you switch the WAF to active, you have a very good level of protection for your web applications. Now, this policy or this way of thinking is a bit different from other vendors. Other vendors will give you a WAF and will tell you, OK, this is the WAF. They will give you a blank page and say, all right, please go ahead, configure your security settings. We think that this can be done. OK, this can be done also with our WAF, but we think that this is too much time consuming if you have to set the WAF from a blank page where maybe the people that are managing the WAF don't have a clue what a request line is. OK, so that's why we have created this baseline, this configuration that you can use or you can change, you can copy, you can do whatever you want, and then you can also improve it. All right, and this is called security policies. Now, security policies are basically applied only to HTTP and HTTPS services for obvious reasons. Okay, we only work with web applications. We don't care about FTP at the moment. We don't care about custom services. So these are the services that we are covering. Of course, Instant SSL is inside this group. Now, a security policy is made of mostly negative elements and some positive elements. Remember the slider? Okay, so we are tending towards the negative here. Why? Because we don't want to have a baseline configuration that is starting to block too much. Otherwise, we will start to have false positives. Okay, so the slider tends towards the negative model. Now, a security policy, it can be assigned to a service or to a content rule. Okay, this will allow you to create something that is called virtual applications or VApps, where you have one IP address, one VIP, and behind this VIP, you have multiple web applications. You might be forced to use this kind of approach because maybe you only have one VIP that you can use. It could be a problem of addressing. It could be a limitation of your environment, like Microsoft Azure. So this will allow you to be very granular. You can have behind the VIP, you can have, for example, an Exchange server with OA and have the OA security policy. You can then have your company's web application and it's written in PHP. You're going to have the PHP security policy for that web application behind the same IP address. Now, by default, the system has 8 predefined policies. These policies were created by Barracuda, by us, and they are created to consider what are the best security settings for this environment without compromising the functionality of the web application. Now, the 8 predefined policies are the default, which is a generic policy, which should work with most web applications without, again, compromising them. Then we have Oracle, OA, from the general version 2013, SharePoint and SharePoint 2013, and SAM for the federated authentication. Okay, this is something that we will touch tomorrow, okay, in the access control. So these are the predefined policies. So what you have to do, essentially, to configure a policy in the WAF, we're going to, let's go to our WAF. We're going to edit a service, like, for example, our bed store service. And as you can see, we have web firewall policy default. That's the default policy that is always assigned to a service when it's created. And if you want, you can then select another policy. And then you can set the WAF, for example, inactive. As soon as you set the WAF inactive, the default policy will be enforced. Now, if you want to see, and you can see here the mode is active. If you want to see all the security policies that the WAF has, you have to use the policy manager. So you go to security policies, policy manager. As you can see, we have default, Oracle, SAM, and so on. All right? Now, in the policy manager, you also have an overview of how policies are configured. And these items that you see on this table are called sub-policies. Every security policy is made of 9 sub-policies. These 9 sub-policies will protect a specific part of your web application. Okay? Not in terms of pages, but in terms of, for example, URL normalization to see if what is inside a URL can actually be then analyzed by the other security policies. Cookies, things that cannot or can be accessed by in your web applications, number of parameters in the URLs, okay? These kind of things. And the 9 sub-policies are applied in the request and in the response. Remember, the WAF doesn't trust anyone, all right? Even the traffic that it's coming from your web servers. So that's why everything is both ways. Now, for the request, we have most of the sub-policies. So we start with request limits. And by the way, this is the way, what you will see here in this diagram, this is the way that they are applied, exactly this order. Okay, so first we have the request limits. So we can put some limits in the request. We have URL normalization, cookie security, global access list, URL and parameter protection, and finally, the action policy. In the response, we still have the action policy, cloaking, data theft protection, and cookie security again. Okay, so these are the 9 sub-policies. We will now see how to configure each one of these sub-policies. Okay, so we will cover each one of them. I will show you what they do, and I will show you what you can configure in these sub-policies. We will go in order, okay, as it is described in this diagram. Unfortunately, the web interface is not created with the same logic. So we will have to jump from one page to another one to configure the sub-policies in this order. All right? But if you keep this diagram in front of you, you will be able to actually follow the whole explanation. Now, let's begin with request limit. Now, request limit will allow you to enforce some limits in the HTTP request. Okay? For example, you can say that the maximum URL length should be defined as a certain limit. The maximum line length, again, should be no more than a certain limit. The whole request should be no more than a certain limit. Whatever falls outside of this limit will be blocked. It doesn't matter if it is an attack or legitimate traffic. Those requests will be blocked. Why do we have these limits in place? Because if you have a request that will basically contain, for example, a max line that is too long, this might generate a buffer overflow, for example, in your web application or in your web server when it's processing the request. Or it might crash your web application because maybe it's not designed. It is not expecting such a long line when it's getting the request. Okay? So you can enforce these limits for the request. Okay? This is the request message. Where do we configure request limits? Security policy, request limits. Okay? First, we have to tell the system which policy we are changing. Okay? In this case, we have the default policy. Is this the policy that we want to change? Let's say no. Let's say that we want to create our own policy. Okay, so let's create a new policy and let's call it bed store. All right, which is based on the default policy. I'm going to click add. All right, now the policy is here, bed store. It is a copy of the default policy, but it's not set yet. You have to go to services and then I'm going to set it to bed store. All right, so now our policy is set to bed store. There is a question. It says, if you change the default policy, does that affect all new policies that are modeled after it? In the past, yes. In the past, if you change the default policy, then you create a new policy, then it was basically a copy of the new settings of the default policy. With version 8.1, this is not the case anymore. In version 8.1, you can create a new policy, which will basically use some default settings, or you can create a new policy based on an existing policy. So if you set here based on default and the default policy was changed, then the new policy will inherit all the changed settings. If you say create new, then you get a default policy, basically, a new policy with the default settings. So in the request limit, we can basically set all the limits, for example, the request length, 32 kilobytes, the maximum request line, 4 kilobytes, the maximum URL length, again, 4 kilobytes. These are all kilobytes, unless you see number of cookies. Okay, these are actually 40 cookies. Okay, always, I was doing the newbie error. Always remember to set the right policy. Okay, when you are changing these limits. So in this case, this is the bed store policy that I want to actually change. Then we have the maximum number of headers, the maximum header name, and so on. All right. Now, for example, let's say that the bed store here is actually working behind my WAF. Let's actually test it. So let's close this, and we have WAF service 00.qw.org. Okay, so now we are going through the web. Now, our web application is working. Let's see what happens if, for example, I will generate a request which was beyond the limits that we have specified in our request limit. So I will use the request generator from Zap, and my get request will then again get the default page. The host is bedstore00.qw.org, and I'm going to, for example, let me just take the WAF again. For example, let's say that I'm going to create a header which name is above this 32 bytes of length. Okay, so I'm going to create a header that does not exist, or actually, yes, it does not exist. Let's call it test. All right, and I'm going to create this header. It's test. Okay, like a very long header, and then the value is 1. All right, let's send this request to the bed store. Sorry, this is WAF service 00. Okay, let's send it. And this is the response, not found. So I am asking basically the default page with this header, and the WAF was in the way. And what the WAF said it just gave me a cryptic error saying, sorry, the URL was not found. But that's not true, because the URL exists. This is just a way for the WAF to mask security issues on your web applications. And it will also mask the security configuration. Okay? So for the WAF, it could be everything is fine, or it could be, yeah, there is a problem. I won't tell you the problem, but there is a problem. Okay? So in this case, the URL is not found. If I try to do the same with bad store here, and I send it, oops, it was really URL not found. Okay, that's bad store. Okay, that's the bad store. Okay, so the bad store replied to me with the page. This is the actual bad store page in the response. Let's do again with WAF service 00. Okay, so it was not that long, apparently. And Zap crashed. So apparently that was a bit too much in the request. Let's see if the request was sent anyway. And let's see if we have something in the web firewall logs. Yes, there we go. OK, header name length exceeded. So Zap crashed, but the header was actually sent to my web application firewall. So we click details in the web firewall log. We will see the reason why this request was blocked. Okay, so we have here the service IP, the VIP, the port, the method was get, the default page, this is what I wanted to get. Protocol is HTTP. The host was webservice00.q2.org. This is the host header. The client IP, this is my Windows workstation. And prevention, the action was denied by a global rule, which is the request limit. And this is why it was blocked. Header name length exceeded. Limits violation, the length it was 140 bytes, and this is the header that blocked that request. Okay? So basically, in this case, if we go to request limit, if this wouldn't been, for example, a legitimate request, then you would have to change this to, for example, 110. Okay, bytes. In this case, this would have gone through the WAF. All right. Whenever you change something like this limit, and then you say, oh, damn, I didn't want to change that, you can click cancel. Okay, cancel will restore the default values in the page. Okay, so you don't have to remember what was the value before you changed it. There is a question, can you show me where WAF service has been configured? Sure, WAF service is basically replying to this VIP, okay, 10.1.30.140. We have a DNS server, and then if you do an NS lookup of WAF service 00.q2u.org, you see that WAF service 00 is resolved as 10.1.30.140. So this is where it is configured. Okay, we got DNS for name resolutions. So essentially, this is what you can do with the request limits. The next sub-policy is called URL normalization. Now, when you send data over the wire in an HTTP request, all that data is encoded. Why it is encoded? This is an heritage that we have from the old days when modems were used, when you dial-up modems were used. Now, those modems used AT commands to open channels, to open the line, dial a number, and so on. And those AT commands were actually words, okay? That's like call or and other words. Now, the problem was that when you were starting to send traffic over the wire, if that traffic was basically words, like a web page, some of that words might have been interpreted as commands by the modems. So we needed a way to let data go through the modem over the wire without commanding the modem. So that's why when we send something over the wire, we encode it. Normally, everything is base 64 encoded. For web applications, things are different. We sometimes use base 64, but most of the times we use the URL encoding. Okay? For example, when you see percentage something or the plus, like if you want to go to a website, you cannot do, for example, www.bbc.com.co.uk and then here having news space live. Okay, this will not work. This is not a valid URL. If this would have been the name of a URL with the space, you would have needed plus. Okay, but this doesn't make sense on web pages. But this is the concept. You have to encode everything before you send it over the wire. Now, the thing is that encoding can be used also by attackers to obfuscate attacks. Okay, so whatever you see here on the request, this is actually a SQL injection, but this is not in clear text. So if you try to apply an attack pattern here on this request, it will not match because there is no attack pattern that will match percentage 27 plus or plus 1 percentage 3D1. No, this is not an attack. So what the WAF will do, it will say, OK, let me see what we really have here. And so it will decode the encoded request. And from this moment on, this is the URL that is going to be used. So the original URL is going to be logged, scrapped, and then this is the new URL that it's going to be used. Okay? URL normalization is active by default as soon as you set to active the WAF, and it is configured in security policies, URL normalization. As I said before, we have to jump. Okay, so here we can set the default character set. That could be UTF-8. You can have ISO, the 8859-1. You can have the Japanese character set. Might be useful for people, for example, from Japan. You can then say if you want to use parameter separators. This is the parameters in the URL. Remember, everything after the question mark, you can use ampersand, ampersand and semicolons, semicolons only. So you can define how your URL should look like. Okay, and then you can also use double decoding. Okay, so in this case, if you have a URL that is decoded twice, you can basically tell the system, please use double decoding. Normally, you don't need to use this. Okay. After URL normalization, we have cookie security. Now, as you have seen from the lab exercise, having a cookie stored in your browser might be a security problem for your web application, especially if in the cookie we set values that are needed by the web application. For example, when you tempered the cookie, changing the price of your shopping cart, that was then used by the browser and sent to the application. The application read the cookie and say, oh, look at that. We got 3 items and the cost is $1. All right, that's what I'm going to charge you for these 3 items, $1. Okay. Now, of course, modern online shopping websites don't work like this. Okay, this Bed Store web application is developed in a way that it can be hacked easily, just to prove a concept. Okay, but let's say that even normal web applications might have some issues when we talk about cookies, because cookies can contain important information like sessions, like information about the users, and so on. So you have two ways to protect against cookie tampering, okay? Or even to see what's inside a cookie. You can encrypt a cookie, or you can sign a cookie. Now, what's the difference between encryption and signing? Encryption means that the value of the cookie is replaced with a string that is the encrypted value that is encrypted by the WAF using an encryption string. Okay, so the WAF will take the value of the cookie, it will encrypt it, and then it will paste the encrypted value into the request, actually into the response that is going to the user. Okay. Now, encryption works very well. The problem is that no one except the WAF can see what's inside that cookie. So essentially, if the web application needs to access the cookie because it needs to get some values, let's say that the cookie stores the time zone, okay, then in that case, the web application doesn't know what to do because the cookie is there, but the value is meaningless. It is an encrypted string. So what is going to happen is that the cookies cannot be used by the web application. So you can use encryption, but you have to make sure that your web application doesn't need that cookie. It just needs the value that is stored in the cookie, but while it is transmitted back and forth between the web browser and the web server. So if you cannot use encryption, what you can use is the second model that it's called signing. Signing a cookie will basically allow you to send the clear text cookie to the web browser, and before the cookie is sent, the WAF will sign it. So it will create a signature, and it will add this signature into the request and response headers. So what is happening is that the web browser will then receive two cookies: the clear text cookie with its name and its value, and the signature. Okay, the web application doesn't know anything about the signature. Okay, so it will not use it, but it will use the value of the cookie. Then the browser will send back the cookie and the real cookie and the signature to the WAF. The WAF will then use the signature to see if the cookie has been tampered. If the signature does not match, then the cookie is discarded. The same is for encryption. If somebody tries to tamper with the encryption string, then the cookie is dropped. Okay? Where do we configure cookie security? Cookie security is in the cookie security page, and the default value for our policy is signed. So we are going to sign the cookie. We're not going to encrypt it. We can force a max age in case our web application does not set it. We can also protect against cookie replay attacks. What is a cookie replay attack? A cookie replay attack is the possibility to, for example, sniff a cookie from a session. Let's say we are, again, in Starbucks, drinking our coffee. Somebody steals our session cookie for Facebook, and it will use that cookie to log in with our session. This will allow you to use the IP address, the original IP address, to say, OK, is this the source IP address that I've seen when this cookie was used? Yes. All right. So this is the legitimate owner of the cookie. Or you can use custom headers or IP and custom headers. OK? Why? Because if you use IP here and we are sitting in the same Starbucks and using the same Wi-Fi connection, we are mostly NATed with the same public IP address. So using IP here won't work, right? Because the WAF will see both connections coming from the same IP. Then secure cookie will basically force the secure flag. HTTP only will force the HTTP only flag. Okay, these are forced by the WAF. So it will basically stamp the cookie with the flag if that flag does not exist. Also, we can exempt some cookies. Why do we want to have exempted cookies? Because there are some cookies that are not generated by our web application, but the WAF will see them. Classic example, Google Analytics. Google Analytics uses a couple of cookies, and if you're not careful, what the WAF will do, it will delete all these cookies as soon as the request is going through the WAF. Okay, because the WAF will say, I've never seen these cookies. Who are they? I don't have a signature. I don't have anything about these cookies. Boom, drop. Okay, so if you use Google Analytics, New Relics, and all those external services, make sure that you are exempting these cookies here. Also, you can have, again, not just session information about the user, like time zone, language, and so on. Who cares about this type of cookies, right? That just exempt them, all right? Don't sign them, don't encrypt them. Now, there is a question. Can you explain the signing process again? Of course, I will explain the signing process by showing you what is happening, okay? So let's go to our bet store, okay? Am I logged in? No, I'm not logged in. So I will open an add-on in Firefox that it's called Firebug, okay, which will allow me to see the cookies. Now, I will then log in into the bet store directly without going through the WAF. Okay, so the email address is going to be, the full name, test@test.com, and the password is test. Okay, going to register. Now I have my session ID for the bet store. Okay, of course, as you saw yesterday, this is a base64 and you're an encoded cookie. So then you have to decode it if you want to actually see what's inside this cookie, right? Now, I only have one cookie. If I want to, I could temper this cookie like you did yesterday by changing the role of the user. Now, let's do the same with the WAF. So what I would do, I would delete this cookie. Okay, so if I refresh the page now, no, I don't want to resend. I am unregistered. Okay, this was a session cookie. Cookie does not exist anymore. User does not exist anymore in my browser. Okay, I'm not logged in anymore. So this is the WAF. Let's go. Let's enable Firebug again. Let's see if we have some cookies. We don't have any cookies. Let's register again. Test.com, test. All right, register. Look at that. You have now two cookies. You have the SSOID, which is the session cookie generated by the bet store, and then you have another cookie, which is called BNES_SSOID, which basically is the signature of this cookie. Okay, so if I would try to temper this cookie now, and I will try, for example, to change my role to administrator, this will not work anymore. Because as soon as I send this cookie to the WAF with the tempered parameter, the signature will not work anymore. Okay, because that's what the WAF will do to generate the signature. Okay, it will basically use the original value plus mathematical formula to then generate the signature. And then some values are also taken in consideration. Okay, is it clear now? Yes, of course. If you change anything in this cookie, even the slightly amount of, even if you change a letter here, then the signature will not be valid anymore. So the WAF will drop it. All right. So essentially, this is cookie security. Again, cookie security is enabled even if the WAF is in passive mode. If you don't want to use cookie security for your web policy, set none here. Okay? Good. There is another question. The cookie will remain the same for a user. Yes, if you temper a cookie, what is happening is that that cookie is not valid anymore. So if I tempered with this cookie, okay, and I will try to send this cookie to the WAF. The WAF will drop it before it is sent to the web application. So I might not use anymore this cookie. Okay, I would be like, in this case, this will break this web application because for the web application I'm logged in. Sorry, for my browser I'm logged in, but for the web application we are not logged in. Okay, that's the way that the bad store thinks when it's related to session cookies. Yes, the only way that you have to fix the problem then is to delete your cookie. That's the only way. Or when it expires on the max age. Okay, do you have any questions regarding anything that we have seen so far regarding sub-policies or security policies? All right. If there are no questions, just one last thing before we move on to the global ACLs. Cookie encryption keys are stored in the WAF in the system configuration page, right? This is the encryption key that is going to be used for the encryption of the cookies. And this is the same key that the WAF uses to do URL encryption that we will see later today or tomorrow. Okay, so if you want, you can generate a new encryption key. Okay, and then you can save it. And be careful, because as soon as you generate a new encryption key, all the cookies that were encrypted with the old one encryption key will not be valid anymore. So plan it, please. Okay. Now, honestly, I don't know what they use to do the encryption. If you really want to know it, I have to ask engineering. But this is not affecting the functionality of the WAF. Okay. All right. The next sub-policy is called global ACLs. Now, with global ACLs, we can basically restrict what can be accessed in our web applications. So there are, for example, some files that should never be accessed by the users. Like if you install PHP, the PHP processor on a web server, PHP automatically creates a page that is called phpinfo.php. Now, if you open that page, you will see the whole information about the web server. The name of the server, the IP address, the process that are used, the Apache version, for example, PHP versions, all the modules enabled, and so on. So this is gold for an attacker that is doing reconnaissance. So you want to make sure that even if that file exists, it will not be accessed. Okay? You might be thinking, oh, well, that's easy. I will delete the file. That would solve the problem. Yes, maybe, because maybe you will delete the file, and then, for example, you do apt-get update PHP, and then when PHP is reinstalled, then you got the file again. Then you thought you had deleted the file, and then the file is still there, accessible from anyone. So you can restrict what you can can be accessed by your web application. Now, there are different actions that you can set in these access lists. These access lists are like a network firewall access list, but we don't have source IP, destination IP, protocol, and port in the specification. We have URLs. Okay, so this can be accessed, this cannot be accessed, and so on. Now, the different actions that we have are basically to give you granular control of what can be done with the request. If you set the action to process, it means, all right, you can access this content, but I will forward this request to the next sub-policy, which is URL protection. Okay, so for me, it's OK. For the global ACLs, it's OK that you access this content, but I'm still not sure if this is a valid request or not. So I'm going to take this request and give it to the URL protection. If you set the ACL to allow, this means, all right, you can access the content and you can access it right away. Bypass all the other security checks and access the content. An example for this, the fav icon. The fav icon is a small icon that most web application uses to change the appearance of a tab or the appearance of the upper left corner of a page. Okay, let me see if here it is. This is the fav icon of the bed store. This small BS written in yellow on the upper left corner of the tab. Now, in this case, we don't want to process this request because we are just getting an image. All right. So what you would do, you would create an allow rule that will allow allow the user to fetch the content. Okay, the fav icon without processing it. Then we have deny and deny with log and no log. In this case, the connection is terminated and it's logged or not. And then we have temporary redirect or permanent redirect. Okay, what's the difference between temporary and permanent? If you have a permanent redirect, the WAF has to specify the new location. Okay, so we have to tell the browser that the content is not here, it is somewhere else, and this somewhere else is defined in a header that it's called location. Okay, now when the browser will try to access again this content, it will not use the original URL, it will use the location URL. Okay, because it is permanently redirected. Okay, temporary redirect will basically tell the browser to use the location just for this time. Okay, next time, if you do another request, the web browser will use the original URL, it will get another 302, and then again it will be redirected to the location. Okay, so that's the difference between temporary and permanent. So how do we configure global ACLs? We go to security policies, then we go to global ACLs. And basically, let's analyze a couple of ACLs that are already configured. Here, PHP info. Okay, let's edit this policy, these ACLs. Everyone that is trying to access PHP info.php, it doesn't matter where this page is, deny it with log. Okay, deny and log. What is the deny response? It is the response page. Okay, so this is basically what you can do in the deny. Okay, when you set deny with log and no log, you can say, I want to reset the connection. This is a reset of the TCP session. In this case, boom, you got the warning in the browser. The server cannot be connected, we cannot connect to the server, or something like that. Response page will basically deliver the default page by default. Okay. Of course, you can create more pages in the WAF, and you can customize your response pages. Maybe you can put the logo of your company and so on. In the deny, again, you can say temporary redirect or permanent redirect. So this is actually a good practice. If somebody is trying to access the PHP info page, instead of blocking him, you're going to redirect him to the home page. Okay, so of course something has happened, but then you are basically redirecting the page, the connection to the home page. If you want to redirect directly the user, then you can use temporary redirect or permanent redirect. Okay, so that's basically what you can use. And you have to specify the new location. Okay, this is a redirect URL. In the location, you can basically specify a variable that is %s. %s will basically reuse everything that was in the URL with the new redirection. Okay, so that's something that is specific only for global ACLs and allowed and I rules. So to reuse the URL in the redirection. Another example, favicon. Let's add it. In this case, this is the favicon.ico. The action is allow. That's it. Okay. Now, as you can see, in the global ACLs, we can specify extended match rules. Okay. So nobody will stop you here to do your first, let's say, your first filtering of the connections, based maybe on the client IP, based maybe on the, for example, on the browser, okay, that is using. Okay, maybe it's using a browser that is too old. Okay, a browser that is not compatible to with your web application. So that's basically a way that you can do it. There is a question: can we make a rule where favicon can be opened on Mozilla but not on Chrome? Sure, you can create a rule, and this rule you will create two rules actually. One rule will contain in the user agent here, for example, Firefox, whatever. Now, in the other rule, you will put Chrome. Yes, we can do it right now. Let's call it favicon Firefox. Okay, so you want Firefox, yes, but not Chrome. Okay, so this is going to be favicon.ico. I don't know if it will work because I have the rule already in place, but let's try in case I will actually change it. So the user agent is equal to Firefox. Okay. And the action is allow. Okay. Yeah, it is complaining because we already have this one. So let's change this one. And let's use the extended match here. All right, so now this is valid only for Firefox. Now let's do the same for Chrome. And the URL match is favicon.ico. And extended match is user agent contain. Oh, there is an error. Contains Chrome. Okay. And then it is allow. And let me see if we have an extended match sequence. And this is 2. Right, so now we have the 2 rules. I just have to correct the extended match for Firefox because it's not equal, it's contain. Okay, there is no user agent for Firefox. Yes, for Firefox. Yes, and the action should be deny and log for the other one. That's right. All right, so let's try it. Let's use Firefox. to access web service. Yeah, we got the icon. Hopefully caching is not involved. No, it shouldn't be involved. Later I will check if it is involved. And let's do the same. Oh, we have the icon. Oh, that's a perfect example for troubleshooting. Let's see what happened. Okay, the easiest way to do this is to open the access logs. Basics, access logs. And the last one is my connection. But look at that. Chrome is written with a capital C. That's why it's not working. Let's say Firefox is written differently. Okay, that's most likely Firefox. Okay, Firefox. Come on. Firefox is written with a capital F. Okay, so most likely this is why it's not working. I will try again, and if it's not working, then I will have to move on. Okay, and we'll troubleshoot this during lunch break, but it should work. So global ACLs. Okay, let's go to Firefox. Thinking too much. Right, and Chrome. All right, let's see if Firefox is working. Yes, Firefox is working. You can actually check here. Yes, everything is in the 200. And right. And let's try with Chrome. This must be cached, of course, because now everything is it's cached in Chrome. So let's see if that's true. Let's go to the WAF firewall logs. We have no denied, so the access list somehow is not applied. And I might know the problem. No, that's actually good. I will investigate this. I've actually never tried because normally you don't discriminate by user agent. You do, if you want to do discrimination by user agent, you have to be more specific. But I will investigate this during lunch break. Okay, but essentially this is how you actually configure it. Okay, I don't know why it went through. It should be blocked in Chrome. It could be that Chrome is not actually requesting anything because of the actually tried the last time. Yeah, you see, it is not downloading the fav icon. So you put it somewhere in its cache, and it's not get it. Yeah, even if you put it, if you open an incognito page, I don't think this will work because again, whatever it's cached. Oh, it's so old that you don't have incognito here. No, I don't have incognito. Whenever it's cached, it can be accessed by incognito or normal. Okay, whatever it's new, then normal sessions cannot be accessed by the ones that are cached by incognito. Okay, so let's quickly move to the URL protection so we can finish the policies. URL protection will allow you to restrict some settings in the URL, like parameters, methods, attack types, file uploads, and so on. Normally, you will prevent that the web application will suffer by some URLs that are, for example, too long, or there are some parameters that are repeated. So this will generate an exception in the web application. So it's better actually if I open the WAF directly. Let me close Zap, but in the meantime, it's crashing the whole system. So we go to the WAF, and we go to URL protection. You see that we can restrict the modes: get, add, post, put, connect, and so on. This is where you define the modes. The content types, this is what you want to be transferred. This is the header. The maximum content length, this is for the request body. Okay, remember, we have the line, the headers, blank line, body. Normally, you use the body in post requests. So make sure that you have requests that are within 32K for this. These are the maximum parameters in the URL, so it's 40, or in the post body. Okay, it doesn't matter where they are, 40 is the limit. Maximum upload files, 5. This is the maximum number of files that you can upload in this request. CSRF prevention. What the hell is this? This is cross-site request forgery prevention. Remember the attack, you're logged in, you go to a website, money are transferred from your bank account to another bank account by just browsing another website. You can prevent this type of attack. How? By including a token in the form and in the URLs so that if you don't have that token, you cannot access the web application the way that, for example, will allow you to transfer money. Okay, so you just have to basically set the token, set that you want to use prevention here. This is the maximum parameter name length. Okay, this is like, for example, you have a parameter that is called search query. Okay, this is 64 bytes. That's the maximum length. Then we have the blocker types. Okay, here we start to have we start to use the patterns. Okay, negative model. So we have SQL injection, command injection, cross-site scripting, and so on. Now, if you want to review these parameters, these patterns, and you want to know the difference between SQL injection and SQL injection strict, then you have to go to Advanced, View Internal Patterns. All right, scroll down, you see attack types, and then you have SQL injection strict, and then the normal SQL injection. Okay, it's called medium. All right, so why we have these two types of definition, also for cross-site scripting and so on? Because SQL injection, the patterns, normally are trapping SQL injections, but they are a little bit loose. Okay, so they will not interfere or should not interfere with the web application. If you set SQL injections strict, then in this case, these patterns are already aggressive. Okay, so you might have some web applications that might use some patterns that falls inside this strict category. So wherever you see the attack name and then the attack name strict, you know for sure that if you want a more aggressive configuration, you have to use the strict pattern. But you have to be careful. Okay? In the past, I've seen, for example, web applications that were configured using SQL injections. By default, the developers were using SQL injections to add data into the database, passing through the web application. This is how they designed the web application. Okay, it was easy, of course, but then again, you should consider to put maybe the pattern into passive. As you can see here, you can set a specific pattern, for example, the SQL injection with union command, the one you used yesterday, into passive mode. So in this case, the WEF is active, the pattern is active, okay, the group is active, for example, strict is active, but just for this specific pattern, all right, you are going to set it in a passive mode so you can review in the log what happens when this pattern is matched. Okay, so if you want, you can also go into the libraries and you can create your own attack types. So my attacks. All right, then you add your pattern. Okay, you just have to specify a pattern name, and then you have to use a regex. Okay, so you have to know how to use regular expressions. You can test and validate your pattern, and when it's basically saved, you then go to security policies, URL protection, you scroll down, and then you say, I want to use my attacks, okay, in the custom block attack types. Because maybe you know that that web application is vulnerable if a certain string is injected somewhere. Okay, so you just specify that string. You can, of course, also create some exception patterns. Okay, so this will override anything that is, for example, in the SQL injection patterns. Okay, so this is what you can configure in the URL protection. Just one note regarding the methods. This list is really, really, really restrictive. Okay, with this list, you could not even put a file in a web server if you want to. Okay, if you are uploading a file and you need to use put as a method, this won't work, even if you specify maximum upload files here into 5. So be careful even if you use the default configuration, that you check with web devs that this is what they really want. Also, head. Really? You really want to have head? No, delete it. Okay, who cares about headers? If you don't use it for troubleshooting, maybe you put it and then you remove it. Okay, of course, I was changing the default policy, my mistake. All right, so what we will do now before we move on to parameter protection is that we will do a 15 minutes break. Okay, it's a little bit longer break, and then we will continue with the last sub policies. All right, so see you here in about 15 minutes.